Hello, welcome to my channel. I'm Ameya, and today we are going to see our next problem in ANSYS APDL. This is a step bar problem where we will change the various properties of the element and we will try to simulate it in ANSYS APDL. We will be sticking to link 180 element again because it's just the axial load, and we will try to develop this problem in ANSYS. So let us start. Yeah, so I have started the product launcher. I have given the working directory and a job name. So you can just click on run and it will start my new problem with new job name. Now, the whole process remains same. Only thing is the meshing will change and the properties will change. Okay, so let us start. We will quickly model everything. So starting with preferences, this is also a structural problem. Then going to preprocessor, element type, add, edit, delete, add. We will take a link 180. Okay. Even though the properties of element is changing, we will take only one element and we will change the properties. Okay. Don't add multiple elements unless it is necessary. So you can do, you don't need a real constant. We will go to material property, material model, structural, linear, elastic, isotropic, normal steps which we do. We will just check the properties which we have. It's yeah, 2e5. So we will continue with that 2e5 and zero point 0.3 Poisson's ratio. Even though it is not given, you can always put 0.3. Exit, because there is no change in material property. I will not go and add different materials. Then we will go to sections, link, add. Now here you can see in problem there are three different sections. One section at the start, second section at the middle, and third section. So link element generally don't consider any shape. Okay, because it takes the axial load, the area which that's matter, cross section area, and here we need to find the cross section area. Okay, so I have already found the A1, A2 and A3. We will be inputting this cross section area into our problem. Okay, so we will just go with ID1, say okay, and section name, let's say C1, circle 1, and you can give the area, that is 1256.64. Okay, we will not enter any mass, tension, compression both, and you can say okay. Then we will add one more ID2 with a section name C2, and the area will be 176.7. So we will enter that 176.7. Okay, we will add one more, that is area 3. Section name is C3 and area will be 706.86. 706.86. Okay, keep attention on units. If you are following mm, all the things you will be entering into Newton per mm metric unit, basically following the same scale. Okay, so we will go to modeling, create key points in active coordinate system. Let us see what key points we need to make. So we will take one key point at this end, so 200, then there is 500, so 700, 200, 700 and 900. Three key points we will be taking, and 0 0. So let us go and create. I will apply for once, that is one key point. Then we will create at 200, apply. Then we will go for 700, apply. Then we will go for 900, apply, cancel. So I have four key points. I will just go and create lines for that. Straight line, one here from here, here from here, here from here. Okay, just click and you will get those lines. If you check in isometric plot multiplot, you have three lines. Now after modeling we will go to meshing, and here where we find the most of the changes. Okay, so we discussed about this. In previous video also, there are three important things which we need to understand: the element attributes, size control, and mesh. Okay, so we are changing element attributes here. So going to element attributes set, the first line I am selecting, and for that first line I am taking link 1 and material number to be 1. We don't have any other material, but cross section we have 3 cross sections. So we will be changing basically these cross sections while meshing. So select C1 for now, say OK. Then you can go to set lines, select it, OK. Say I am going for 10 divisions for now and say OK. This is what the sizing will look like. You can go to mesh and this will be a mesh. Plot multiplot, that will give you the mesh out the first section. Now the second step change is in element attribute. You will go to lines again, and instead of first cross section you will go to the second cross section. Okay, and remember what are the different inputs you are giving to a cross section and your name, so that you will get the proper cross section wherever required. Okay, now what we have to do here is second cross section. You can say okay, just set lines and say 10 divisions, and we will mesh it again. Okay, plot multiplot. I will show you in the second time itself what my sections are changing. I will switch on the size and shape. I will switch on the size and shape, and you can see there is a change in cross section. Okay, now it's time for third line, so I'm selecting a third line here. Third cross section. Okay, you can just go and mesh. Oh, sorry, sizing. The second step, 10 sizing, and then you can mesh it. Okay, so this is how everything changes with the first cross section, second cross section, and third cross section. Now my body is completely meshed. I will go to loads, define loads, apply structural displacement on key points, select the key point. Okay, all degrees of freedom. Okay, and load, so I will go to force key point, select a key point. Okay, yeah, the force value is, again we need to check what is my force value. So it is 15 kilonewton, so we will be entering 15,000. Okay, and going towards right side, so it will be positive. So I will shift to my ANSYS window, we'll close this, and this is how you get the pre-processing done for a multi step bar problem. And then you can solve current ls. Okay, there will be a solution done. You can go to pre-processor, general processor, plot results, deform shape, nodal solution, DOF solution, X component. Okay, okay, so you can animate and all do all these things depending upon your requirement. What we are interested in here is we need to find a stress, and if you go to plot result, contour plot, nodal solution, and you try to plot a stress, you will not get those stress in the element 1 mass stress. Okay, you will not get that stress data for the link element. So how to plot the stress, that is the task. So you can go to element table, define table. Before that you can just go to the read result and say the last set. Okay, this is very important step. When you go to the element table, read the last set, and then you can go to element table, define table, add. Element table window will open up, and in that you will go to last, that is by sequence number, ls, and 1. Okay, that will add one element table into your problem. Then you can go to list results, element solution, stress, X component. That will give you the element stress at each node and each element. Okay, same thing you can go with uh, list results, nodal solution, and you can go with X component, stress in X component. That will give you the nodal solution at stress for the each node, okay, maximum value and minimum value. Okay, so this is the tricky part which we need to understand, the stress calculation for link 180 element. Okay, and that is what we have done in this video. So a step bar with axial load and a calculation of stress in ANSYS APDL. Okay, so that's it for this video. We will be coming with more videos on ANSYS APDL. So do follow my channel, subscribe my channel, and if you like this content, share a word with your friends. Thank you for joining.